Hi Ducks, welcome back to DuckFlix. Today we will be covering our last lesson of Unit 9, 9.7, Graphing and Analyzing Relationships. Please take a minute to review our lesson scale. Remember, by the end of this lesson, we want you to independently be at a level 3 and be able to analyze and display data in a coordinate plane using two numerical patterns by creating a line graph with ordered pairs. Now you're probably thinking to yourself, this sounds familiar, this is what we've been doing. And yes, that is absolutely correct. We are going to be applying all of the different lessons and skills that we've been learning, and we're going to put those all into one to be able to demonstrate that we have an understanding of these skills. Go ahead and pause the video so you can record your lesson scale and your beginning of lesson number. Let's take a look at the standards for mathematical practice. Remember, as we problem solve, we want to make sense of these problems and persevere. We want to keep on going. We want to think to ourselves, what makes sense by reasoning? We also want to be able to attend to precision. It's always important to check our work. We want to look for and make sense of patterns and make connections. So number 7 and 8 are really important. These practices are super important for this particular lesson. And then of course we're going to be graphing, so we can be using different types of models. In this instance, a line plot in the coordinate grid in order to show our understanding. Let's go ahead and take a look at the I Do. We have the 5th grade that is having a St. Patrick's Day party at school, and they are planning to make leprechaun punch. For each cup of punch, they will use 3 tablespoons of punch mix and 6 fluid ounces of water. Okay, so you can see that we have our 3 tablespoons, 6 fluid ounces of water filled into the first section of our chart. So if they use an 18 tablespoon canister of punch mix, okay, that's how much the entire can holds, we want to know how many fluid ounces of water will be needed in total. Okay, so if we start with 3, and we then end up with 18, we have to think to ourselves, between each one of these batches of punch, how much are we adding in the sequence to get to our 18? Okay, so between the 3 and the 18, we have 1, 2, 3 unknown numbers. Okay, so if we have 5 batches in total, and we start with our 3 tablespoons, we have to figure out how much we're going to skip count by. How much are we going to add each time to get to that 18? Well, if I add 2 each time, I'm going to fall short. Okay, so if I add 3 each time, our next number would be 6. Okay, so I added 3. If I add 3 again, I'm going to get to 9. And if I add 3 again, I'm going to get to 12. And if I add 3 again, I'm going to get to 16. Oops, left that out. Or no, sorry, 15. 15, excuse me. And then if I added 3 again, I would then get to my 18. Okay, so sorry, I left this little column out. Okay, so now if we have our sequence rule, okay, for the tablespoons, our tablespoons are add 3. Okay, and I also could have thought to myself 3 times what number, because we have 1, 2, 3, 4, 5 more slots to fill is going to get me to 18. Well, if I already have 3 times 5 more batches is 15, and 15 plus 3 is going to get me to that 18. Okay, so now let's go ahead and fill in the relationship. Okay, so the relationship between the tablespoons and fluid ounces. I'm going to come back to the sequence rule. Okay, the relationship between the 3 and the 6, we need to think to ourselves, what can I multiply the 3 by to get to 6? Well, we know that we're going to be multiplying by 2. Multiply by 2. Well, if I continue that relationship, if I multiply 6 tablespoons by 2 fluid ounces, I know I'm going to get 12. And what is the difference between 6 and 12? We can either say we can add 6, okay, you can add 6. Actually, that's what we're going to say. So for our sequence rule, we're going to have add 6. That's going to be our sequence rule. And if we keep going with that rule, we will have 18, 24, and 30 for our little column I left out, and 36. Now, before we graph, I want you to think to yourself, how are the table, okay, that we created, the rule that relates to the amount of punch mix to water, and your graph all related? How do all those things relate? Okay, they all represent the same thing, just in different ways. They all represent the same thing. So just as the table shows the number of pairs that relate to the amount of tablespoons to fluid ounces, our rule shows the relationships in words to multiply the number of tablespoons of punch mix to find the number of fluid ounces of water to use. And then in the graph, we're going to show the relationship as a line. And it's going to show the relationship of the number of fluid ounces of water. And you're going to understand that it's always twice as much as the x-coordinate. So let's go ahead and graph it. So we know that we have punch mix in tablespoons. And we have water in fluid ounces. And this is showing the relationship of how much water will be used for an 18 tablespoon canister of punch mix. So water used for punch. Okay, so there's my title. All right, now because we're working with fairly small numbers, I'm going to go ahead and we're going to just show the increments down on the x-axis, counting in threes. We'll just do 3, 6, 9, 12, 15, 18. Okay, and then along the y-axis, we have starting at 6 all the way to 36, so I think it's best to probably count by 5s. We can count by 5. So we'll just, this is our 0, this is our origin, and we'll say 5, 10, 15, 20, 25, 30, 35, 40. Okay, so our first ordered pair is going to be 3 tablespoons, 6 fluid ounces. Okay, so it's probably around there. Okay, then we're going to have 6 tablespoons, and we're going to be at about 12 fluid ounces. And then we're going to have 9 tablespoons, and we're going to graph 18. Okay, and then so on. So now we'll have 12, and we're going to go up to 24. Okay, and we can see that the amount of water increases as we have more tablespoons of punch. So now 15, we're going to go up to 30. And 18, we're going to graph at 36. And we want to try to graph this in a straight line. Obviously, my finger is a little bit shaky. Okay. But you can see we should have a fairly straight line showing an upward trend or increase in fluid ounces. So then we're going to want to label each one of these. We want to label each ordered pair. 6, 12, 9, 18, 12, 24, 15, 30, in 1836. So to answer our question, we can say that we will need to use 36 fluid ounces of water will be needed, okay? Because all the way up here, if we use the entire canister, 36 fluid ounces. All right, now let's go on to the we do. Okay, this time we have Mackenzie's making a scarf. She needs to buy 3 1/2 feet of fabric, but it is sold in inches. She knows there are 12 inches in 1 foot, so how many inches of fabric will she need? Okay, so she needs to buy 3 1/2 feet of this fabric. It's only sold in inches, and she knows that there are 12 inches in 1 foot. We want to know how many inches of fabric will she need? How many inches? Well, in the chart, it gives us that 1 inch is 12 feet, okay? And so if we know that 1 inch is 12 feet, then we would know automatically that 2 feet is going to be 24 inches, okay? So it's basically going to double, okay? Each time the relationship is going to be times 12. Because 1 times 12 is 12, 2 times 12 is 24, and so on. So then we'll have 36, and we'll have 48. Okay, but the real thing that I want to show you here is that we need 3 1/2. We need this number right here that doesn't exist. So we need to think to ourselves between which 2 whole numbers is 3 1/2. And we can say that it is between 3 and 4. So now, let's go over to our graph, and we're going to start, our origin is 0, and we're going to go in 1/2 increments. We're going to go 1/2, 1, 1 1/2, 2, 2 1/2, 3, 3 1/2, 4, okay, and these are feet, okay, and then the y-axis is going to be our inches, because we want to know how many inches of fabric she's going to need, based on the amount of feet that she needs. And because we're starting with 12 and we're ending up at 48, I'm going to go ahead and do intervals of 6. I'm going to go all the way up to about 60. Okay, so we'll go by 6s. We'll go 6, 12, 18, 24, 30, 36, 42, 48, and I'll just go 54, 60. Okay, so 0 to 60. All right, so now we need to plot these points, okay? So we know that if we have 1 inch, okay, 1 inch would be 12 feet. So, 1 inch would be 12 feet. And I just realized I had these labeled incorrectly. So this is actually feet. And I'm sure if you were in class, you would have caught me. And this is inches. So now that makes more sense. I went to plot it and it made no sense. So if I go to 1 foot, I'm going to have 12 inches. If I go to 2 feet, I'm going to have 24 inches. If I go to 3 feet, I'm going to have 36 inches. And if I go to 4 feet, I'm going to have 48 inches. Okay, so now I'm going to connect these in a line. Okay, try to make it kind of straight. Okay, good enough. And if I want 3 1/2 feet, I'm going to see where 3 1/2 meets the line. Okay? Oops, that's 3. Okay, let me move one over. So if I go to 3 1/2 and I see where it meets my line, okay, I can see that 3 1/2 is going to meet my line plot, or my line graph at 42 inches. So she would need 42 inches of fabric. Okay, now please do the Okay, now I want you to try it on your own. I didn't create a new problem, but I want you to graph it here and see if you are able to do it. So this would be more of the you do. And you can go back to the previous screen to see if your answer is correct. And then I want you to rate your learning, and we will see you in class.